Nara, Japan, 594. While temple carpenters across the realm rushed to fell fresh hinoki cypress and build Prince Shotoku's Buddhist temples within months, Master Shigemitsu Kongo was walking through ancient forests with a blade, killing towering trees where they stood. Fellow craftsmen called it wasteful superstition. Imperial commissioners questioned the expense. Why girdle perfectly good timber 4 feet in diameter and let it rot for years when green lumber worked just fine? Shigemitsu spent 3 to 5 years maintaining dead trees like tombstones, while rivals completed entire temples using woodcut and used within months. His fellow builders laughed at the foreign technique. Court officials couldn't believe such backward methods when Chinese and Korean masters built efficiently with fresh timber. Then the test of time arrived. The Great Fire of 670 destroyed most of Nara. Earthquakes toppled newer pagodas across Japan. Temples built with conventional quick-dried lumber crumbled within decades, requiring constant repairs and complete reconstruction. But Shigemitsu's Horyuji, the central pillar cut from his original 594 tree, still stands unmoved after 14 centuries. Modern pressure-treated lumber fails after 50 years despite toxic chemicals, yet his ancient timber shows negligible decay after 1,500 years. What did this one carpenter understand about wood death and natural preservation that everyone else missed? If you value stories of ancient craftsmanship that modern science finally validated, make sure to subscribe. We've got more documented techniques worth discovering. The morning mist clung to the ancient hinoki cypress groves near Nara as master carpenter Shigemitsu Kongo moved between towering trees, his weathered hands running across bark that had grown for over 2 centuries. Each cypress stretched 160 feet toward the heavens, their trunks measuring 4 feet in diameter, giants that had witnessed the arrival of Buddhism from the Korean peninsula and the rise of the Yamato court. While temple construction teams across the realm worked frantically to complete Prince Shotoku's ambitious building program, Shigemitsu carried a different tool than his peers. Not the sharp bite of a felling axe, but a curved blade designed for precision cuts through living bark. The tachikare method had been whispered among the most traditional Miyadaiku families for generations, passed down from Chinese and Korean master builders who understood that truly permanent structures required timber prepared through natural death rather than violent harvest. Shigemitsu's grandfather had taught him to read the subtle signs that marked a tree ready for standing death, the slight lean that indicated perfect heartwood density, the absence of insect damage that would compromise the slow dying process, the grain patterns visible through thin bark sections that promised minimal splitting during the years ahead. This was not mere superstition, but accumulated wisdom from craftsmen who built to outlast dynasties rather than satisfy impatient patrons. As Shigemitsu pressed his blade into the first cypress, cutting a precise ring through the cambium layer that would slowly starve the massive tree of nutrients, the sound of conventional construction echoed from valleys below. Master joiner Takumi, Notori's crews had already felled dozens of trees for the Wakakusa temple project, their saws biting through green timber that would be shaped and assembled within months. The contrast could not have been starker, while Shigemitsu killed his trees to begin a process that would span years. His competitors raced to complete entire structures before the next monsoon season. Imperial Building Commissioner Soga no Umako arrived at the grove 3 days later, his silk robes and polished leather boots marking him as a man more comfortable in palace halls than forest clearings. He had overseen the construction of 7 temples across the Yamato region using imported Chinese techniques that emphasized speed and efficiency, and Shigemitsu's methods struck him as wastefully backward. The prince expects devotional structures completed within 2 years, Umako declared, gesturing toward the girdled trees that would stand like monuments to inefficiency. Your competitors will frame 3 temples while these trees rot in place. The criticism extended beyond imperial circles into the tight community of temple builders who had recently arrived from Korea and China, bringing architectural knowledge that transformed Japanese construction. These foreign masters had built the great temples of Baekje and Tang dynasty monasteries using timber cut and seasoned for 6 to 12 months maximum, methods that produced magnificent structures within reasonable time frames. When word spread that Shigemitsu intended to maintain his dead trees for 3 to 5 years before even beginning the seasoning process, the mockery was swift and merciless. Fellow craftsmen called it primitive superstition, a stubborn adherence to indigenous practices when superior foreign techniques were freely available. The financial burden of the tachikare method created additional pressure from court officials who controlled construction budgets. Maintaining dead trees required constant vigilance against fire, theft, and storm damage over years rather than months. Shigemitsu had to assign apprentices to guard the dying giants, prevent unauthorized harvesting by other building projects, and protect the valuable timber from the frequent fires that swept through Japanese forests during dry seasons. The expense of this extended protection period made his approach 3 times more costly than conventional methods before a single beam was cut. Master Takumi no Tori made his criticism public during the autumn gathering of temple builders in 600, when construction guilds met to share techniques and coordinate projects. Standing before assembled craftsmen, he pointed toward the Wakakusa temple, rising with remarkable speed, using green lumber felled and shaped within 8 months. Shigemitsu clings to forest magic while we build with proven methods, Takumi declared. His trees stand dead while our temples house monks and serve the Buddha's teachings. The assembled builders nodded approvingly. Visible results trumped theoretical improvements that might materialize years in the future. Even Prince Shotoku faced pressure to abandon Shigemitsu's expensive and time-consuming approach. Court advisors questioned the wisdom of supporting techniques that required decades to complete when political circumstances demanded swift demonstration of Buddhist devotion. Other regional lords were commissioning temples that rose within seasons, creating impressive monuments to their piety, while Shigemitsu's forest remained a graveyard of deliberately killed trees. The prince's support became crucial protection against mounting criticism from practical administrators who measured success in completed structures rather than theoretical longevity. The standing death process itself appeared deceptively simple, but required precise knowledge passed down through generations of specialized craftsmen. Shigemitsu's cuts had to penetrate exactly deep enough to sever the cambium layer without creating entry points for insects or fungi that would compromise the slow drying process. The timing of girdling followed ancient calculations based on sap flow cycles, lunar phases, and seasonal weather patterns. Knowledge that separated true miyadaiku, masters from ordinary carpenters who worked with readily available materials. As the first year passed and Shigemitsu's cypresses began their gradual transformation from living giants to perfectly preserved timber, the contrast with conventional methods became increasingly apparent. Takumi no Tori's Wakakusa temple suffered its first structural problems when green lumber began shrinking and checking, creating gaps in joints that had been perfectly fitted during construction. Other quick-built temples reported similar issues, posts developing splits, roof beams sagging as moisture content dropped unevenly, entire sections requiring costly repairs within their first decade of service. Yet Shigemitsu's trees continued their patient death, invisible chemical changes occurring within the heartwood as natural preservatives concentrated, and moisture content dropped from 150% to below 20% over 4 years. The wisdom of standing death lay not in dramatic visible transformation, but in microscopic processes that modern science would not understand for over a millennium. The polymerization of natural resins into powerful fungicides, the gradual elimination of sugars that attracted boring insects, and the development of dense cellular structures impossible to achieve through any form of artificial seasoning. By the second year of standing death, the invisible transformation within Shigemitsu's girdled cypresses had begun in earnest, though outwardly the trees appeared as lifeless monuments to questionable judgment. The cambium cuts had sealed themselves with hardened resin, creating natural barriers that prevented both moisture loss and fungal invasion, while the massive trunks slowly consumed their remaining nutrients. Deep within the heartwood, cellular changes occurred that would not be understood by modern wood science for over 13 centuries. The gradual polymerization of natural preservatives as living processes ceased, and protective compounds concentrated into permanent barriers against decay. Master Takumi no Tori's Wakakusa Temple, meanwhile, had become a showcase of efficient construction methods that impressed visiting officials and foreign dignitaries. Completed within 18 months using timber cut and shaped immediately after felling, the structure demonstrated the superiority of imported Chinese techniques over primitive indigenous methods. The green lumber had been shaped while still pliable, joints fitted with precision impossible to achieve after extended seasoning, and the entire complex assembled with remarkable speed. Court officials praised Takumi's practical approach, noting that functional temples served Buddhist devotion far better than theoretical improvements that existed only in forest graveyards. The first signs of trouble appeared during the temple's second winter, when sharp temperature fluctuations caused the green lumber to contract unevenly. Joints that had been perfectly fitted during construction began opening as moisture content dropped from over 100% to roughly 60% within months, a rapid drying process that created internal stresses the original builders had not anticipated. The main hall's central posts developed hairline cracks parallel to the grain, while roof beams showed checking patterns that compromised their structural integrity. Takumi dismissed these issues as normal settling that could be addressed during routine maintenance. Imperial Building Commissioner Umako documented similar problems across multiple temples constructed using conventional quick-build methods. His reports to the court noted that 7 of 9 recently completed temples required significant repairs within their first 5 years of service. Posts had twisted as uneven drying created internal tensions. Roof timbers had warped beyond their original specifications, and entire sections showed premature weathering, where protective finishes failed to penetrate timber that retained high internal moisture content. The pattern suggested systematic problems with rapid construction techniques rather than isolated construction defects. Shigemitsu's standing cypresses, by contrast, underwent precisely controlled moisture reduction that eliminated the violent stresses plaguing quick-dried timber. The tachikare process allowed water content to drop gradually over years rather than months, preventing the rapid cellular collapse that created checking and splitting in conventionally processed wood. As living processes ceased, the trees concentrated natural fungicides and insecticides into permanent preservatives, while cellular walls thickened and strengthened, changes impossible to replicate through any form of artificial seasoning or chemical treatment. The third year brought more serious structural failures to temples built with green lumber. The Askadera's western pagoda developed a pronounced lean when foundation posts compressed unevenly under load, their green timber shrinking at different rates depending on grain orientation and original moisture content. Master joiner Yamashina, who had praised quick construction methods during the temple's dedication ceremony, now faced costly reconstruction of major structural elements barely 3 years after completion. His detailed records showed timber shrinkage exceeding 12% in some members, creating gaps in joints that had been precision fitted during assembly. Prince Shotoku visited Shigemitsu's forest during the cypress tree's 4th year of standing death, walking among the towering corpses that had become symbols of either patient wisdom or wasteful obstinacy, depending on one's perspective. The trees showed remarkable preservation despite years of exposure to weather, their bark tight and unblemished, their heartwood slowly transforming into material that would outlast empires. The prince understood that his political support for this extended process had become increasingly difficult to justify as other lords completed multiple temples, while Shigemitsu's project remained invisible to all but the most discerning observers. The standing death process reached its crucial phase during the 4th and 5th years, when moisture content within the heartwood stabilized below 20%, a level that prevented fungal colonization while maintaining sufficient flexibility for precision joinery. Modern lumber kilns operated at temperatures exceeding 200 degrees could reduce moisture content rapidly, but created brittle timber with compromised cellular structure that aged poorly over decades. Shigemitsu's cypresses achieved optimal moisture levels through natural processes that preserved cellular integrity while eliminating the sugars and starches that attracted boring insects and decay organisms. Competing temple projects faced escalating maintenance costs as their green lumber continued aging poorly. The Tachibana Dera required complete replacement of its main gate after only 8 years when posts rotted at ground level, their high moisture content during installation having created perfect conditions for fungal attack despite surface treatments with traditional preservatives. Master builder Kuratsu Kuri, who had initially mocked Shigemitsu's forest methods, now spent significant resources repairing structures that should have remained sound for decades under normal circumstances. The contrast became undeniable when imperial inspectors conducted systematic evaluations of temple construction quality during the reign's 10th year. Their detailed reports documented structural problems across every temple built with conventional quick-drying methods, warping that compromised architectural lines, checking that allowed moisture infiltration, and premature aging that required costly maintenance within single decades. The patterns suggested fundamental flaws in imported construction techniques when applied to Japanese timber species and climate conditions. Abbot Eiji of the planned Horyuji Monastery maintained detailed records of these comparative failures, documenting evidence that traditional Japanese timber preparation methods produce superior long-term results, despite requiring decades rather than seasons to complete. His writings preserved crucial technical details about the tachikare process that would guide temple restoration projects over subsequent centuries, including precise measurements of moisture content, reduction, optimal timing for different seasonal conditions, and specific indicators that marked successful completion of the standing death cycle. By 599, Shigemitsu's cypresses had completed their transformation from living giants to perfectly preserved construction timber through natural processes that compressed centuries of aging into 5 controlled years. The trees stood ready for harvest, their heartwood stabilized at optimal moisture levels, while competitor temples built with green lumber faced mounting structural problems that would plague them throughout their abbreviated lifespans. The stage was set for construction that would prove the superiority of patient traditional methods over hasty imported techniques. The autumn of 600 marked the beginning of Shigemitsu's most controversial phase as he finally felled his perfectly preserved cypresses after 5 years of standing death, only to store the massive logs in carefully constructed seasoning sheds for what he announced would be another 10 to 20 years of controlled aging. The decision sparked renewed criticism from imperial officials who had assumed that felling the trees would signal the immediate start of construction on Prince Shotoku's long-delayed temple project. Instead, Shigemitsu's apprentices spent months building elaborate storage facilities with precisely calculated ventilation systems designed to continue the timber preparation process through what traditional Miyadaiku called kusare dome, the stopping of rot through perfect environmental control. The seasoning sheds themselves represented centuries of accumulated knowledge about timber preservation that had been refined through generations of temple builders. Each structure featured adjustable wooden louvers that could regulate airflow based on seasonal humidity changes, raised floors that prevented ground moisture from affecting stored lumber, and precisely angled roof lines that shed rain while allowing controlled air circulation. Shigemitsu positioned the sheds to take advantage of prevailing wind patterns while protecting the valuable timber from direct sunlight that could cause surface checking during the critical early months of post-harvest seasoning. Master Takumi no Tori's public criticism reached new heights as he observed Shigemitsu's latest delay in actual construction. Standing before assembled craftsmen at the annual guild meeting, Takumi pointed toward his own completed projects. 3 temples that had risen using conventional methods while Shigemitsu's timber aged in expensive storage facilities. The Buddha teaches the middle path, Takumi declared, yet Shigemitsu chooses extremes that serve no practical purpose. My temples house monks and serve the faithful, while his wood sleeps in palaces more elaborate than some shrines. The gathered builders laughed appreciatively, viewing Shigemitsu's methods as the stubborn eccentricity of a craftsman who had lost sight of construction's ultimate purpose. The kusare dome process itself involved far more than simple storage, requiring constant monitoring and adjustment of environmental conditions to achieve optimal results. Shigemitsu's apprentices checked humidity levels daily, using traditional methods that relied on observing how thin wood shavings curled in response to atmospheric moisture, adjusted ventilation openings based on seasonal weather patterns, and rotated timber positions to ensure even exposure to controlled airflow. The logs were stacked with precise spacing calculated to maximize air circulation while preventing warping, each piece separated by carefully shaped blocking that maintained proper alignment during the extended seasoning period. Imperial Building Commissioner Umako's frustration with the project's timeline reached a crisis point during the 7th year, when political pressure for visible progress intensified following the completion of rival temples across neighboring provinces. Other regional lords had commissioned and dedicated multiple Buddhist structures, while Prince Shotoku's most ambitious project remained a collection of aging lumber and storage sheds. Umako threatened to reassign the commission to Master Takumi, whose proven track record of rapid completion would satisfy court officials who measured success in dedicated temples rather than theoretical timber improvements that might never be tested. The extended seasoning process achieved microscopic improvements that would not be understood until modern wood science developed sophisticated analytical techniques 13 centuries later. As the felled timber aged in controlled conditions, residual moisture equalized throughout each log's cross-section, eliminating the internal stress gradients that caused warping and checking in rapidly. Dried lumber. Volatile organic compounds that attracted boring insects gradually dissipated, while natural resin distribution became uniform throughout the heartwood, creating timber with properties impossible to achieve through any form of accelerated processing or chemical treatment. Prince Shotoku's political situation grew increasingly precarious as court advisors questioned the wisdom of supporting construction methods that seemed designed to delay completion indefinitely. The prince faced mounting criticism from Buddhist clergy who argued that unbuilt temples served no religious purpose, from court officials who viewed the project as evidence of poor administrative judgment, and from rival nobles who used the delays to question his commitment to spreading Buddhist teachings throughout the realm. Only the prince's personal conviction that permanent structures required permanent methods prevented the project's cancellation during its most vulnerable period. The great political upheaval of 645 brought the Taika reforms that fundamentally restructured Japanese government, creating new pressures for rapid completion of visible construction projects that would demonstrate imperial authority under the reformed system. The political chaos that accompanied these changes destroyed or damaged numerous temples across the archipelago as rival factions fought for control of regional power centers. Temples built with conventional quick construction methods proved particularly vulnerable to the fires and warfare that swept through settled areas during the transition period, their inadequately seasoned timber creating structures that burned rapidly once ignited. Master Takumi's Wakakusa Temple fell victim to the political violence when rival Buddhist sects clashed over monastery control during the reform's second year. The temple's green lumber construction, which had seemed advantageous during rapid assembly, proved catastrophic when arsonists targeted the structure. The high moisture content that had created construction difficulties also made the building burn with unusual intensity, consuming decades of artistic work in a single night. Similar disasters struck other rapidly built temples, whose timber had never achieved the low moisture content that provided natural fire resistance. Shigemitsu finally began construction of Horyuji in 607, using timber that had undergone 15 to 25 years of total preparation from initial girdling through controlled seasoning. The lumber possessed qualities that amazed even experienced craftsmen. Perfect dimensional stability that allowed joints to be cut with tolerances measured in fractions of inches, natural resistance to insect attack that eliminated the need for chemical treatments, and density patterns that had concentrated the wood's strongest fibers while eliminating weak sections through the extended preparation process. The contrast with conventional construction, materials became immediately apparent as Shigemitsu's crews began shaping the perfectly prepared timber. Where green lumber required constant adjustment as it dried and warped during construction, Shigemitsu's aged cypresses maintained their dimensions precisely throughout the building process. Joints cut during the frame's assembly remained tight after decades of service, while surface finishes penetrated deeply into the stable wood structure to provide lasting protection against weather and wear. Abadeji documented the construction process in unprecedented detail, recording measurements and techniques that preserved traditional Miyadaiku knowledge for future generations of temple builders. His records noted that Shigemitsu's timber required significantly less shaping than green lumber to achieve perfect fits, that joints could be cut with precision impossible when working with wood that continued changing dimensions during assembly, and that the finished structure exhibited stability that eliminated the settling problems that plagued conventionally built temples throughout their first decades of service. The Horyuji Pagoda rose through 608 and 609 with a structural stability that impressed even skeptical observers. Its 5-story frame assembled using joinery techniques that required no metal fasteners yet created connections stronger than iron bonds. Shigemitsu's perfectly aged timber allowed for tolerances impossible with green lumber, joints that fit with mathematical precision, load-bearing members that maintained their dimensions exactly, and an overall framework that exhibited none of the settling and adjustment problems that plagued conventionally built temples throughout their first decades of service. The central pillar, carved from the original cypress girdled in 594, stood as a monument to patient craftsmanship that had transformed a living tree into construction material of unprecedented quality. Within 30 years of completion, the first dramatic tests of Shigemitsu's methods arrived as political upheaval and natural disasters struck temples across the Japanese archipelago. The Great Fire of 670 consumed vast sections of the ancient capital, its flames spreading through wooden structures with devastating efficiency as dry summer conditions turned the densely built city into a tinderbox. Temple after temple built with conventional quick-dried lumber fed the conflagration, their inadequately seasoned timber burning with unusual intensity as residual moisture created steam explosions that spread flames faster than firefighting crews could respond. The Yakushiji's Eastern Pagoda, completed just 15 years earlier using Master Takumi's efficient construction methods, became a towering torch that illuminated the night sky as flames consumed its green lumber framework within hours. The temple's monks watched helplessly as decades of artistic treasures disappeared in smoke, the structure's rapid construction proving catastrophic when subjected to fire's ultimate test. Similar disasters struck other quickly built temples, whose timber retained enough moisture to create explosive combustion once ignited, while their resin-rich heartwood had never achieved the concentration levels that provided natural fire resistance. Horyuji's structures, by contrast, stood untouched as flames swept around them, their perfectly seasoned timber proving remarkably resistant to ignition, despite direct exposure to flying embers and radiant heat. Shigemitsu's extended preparation process had reduced moisture content to levels that eliminated explosive steam production while concentrating natural fire-retardant compounds throughout the heartwood. The pagoda's central pillar, with its dense cellular structure created through decades of controlled aging, simply refused to burn despite temperatures that consumed neighboring buildings constructed with inferior materials. The earthquakes that regularly shook the Japanese islands provided another severe test of construction methods, as seismic forces exposed fundamental differences between timber prepared through patient traditional techniques and lumber processed through hasty conventional methods. The Todaiji's Western Hall, built using imported Chinese rapid construction techniques, suffered major structural damage during the 703 earthquake when inadequately seasoned posts compressed unevenly under lateral loads. The green lumber's continuing dimensional changes had created gaps in critical joints that became failure points when seismic stress tested the structure's integrity. Shigemitsu's pagoda, however, demonstrated the superior earthquake resistance that traditional Miyadaiku had built into their designs through centuries of experience with Japan's unstable geology. The extended timber preparation process had eliminated the internal stresses that caused conventional lumber to fail under dynamic loading, while the perfectly fitted joints created flexible connections that absorbed seismic energy without structural damage. Modern engineering analysis would later confirm that Shigemitsu's joinery techniques created earthquake-resistant connections superior to many contemporary steel frame designs. The most compelling evidence of superior construction methods emerged through careful observation of long-term structural performance as temples built with different techniques aged over subsequent centuries. Master Takumi's surviving temples required major reconstruction work within 50 to 70 years as their inadequately prepared timber aged poorly, developing rot at critical connection points where moisture had been trapped during original construction. Posts began failing at ground level where high moisture content during installation created perfect conditions for fungal attack, while roof timbers warped beyond acceptable limits as uneven drying continued decades after completion. Imperial building inspectors documented these systematic failures in reports that confirmed Shigemitsu's predictions about the long-term consequences of hasty construction methods. Their surveys revealed that temples built with green lumber required complete replacement of major structural elements within single lifespans, while maintenance costs escalated rapidly as inadequately seasoned timber aged poorly under normal service conditions. The patterns suggested fundamental flaws in imported construction techniques that prioritized rapid completion over structural longevity. Horyuji's timbers, meanwhile, showed negligible deterioration even after centuries of service in Japan's humid climate, with its cycles of typhoons, earthquakes, and seasonal temperature extremes. The pagoda's central pillar remained dimensionally stable and structurally sound, its cellular structure preserved through Shigemitsu's patient preparation methods that had eliminated the biological processes causing decay in conventional lumber. Periodic inspections revealed timber that appeared virtually unchanged from its original condition, with natural preservatives concentrated during the standing death process, continuing to protect against insect attack and fungal colonization. The vindication of traditional methods became undeniable when modern analytical techniques confirmed what careful observers had suspected for centuries, that Shigemitsu's timber possessed properties unachievable through any form of accelerated processing or chemical treatment. Dendrochronological analysis revealed cellular structures that remained intact after 14 centuries of service, with negligible degradation in load-bearing capacity despite exposure to conditions that destroyed conventionally prepared lumber within decades. The microscopic examination showed how the extended preparation process had created dense, resin-rich heartwood that microorganisms simply could not metabolize. Contemporary temple restoration projects began mandating traditional tachikare techniques that had been abandoned for centuries in favor of modern rapid processing methods that promised immediate results but delivered inferior long-term performance. UNESCO's recognition of Horyuji as the world's oldest surviving wooden structures validated Shigemitsu's patient approach to timber preparation, acknowledging that working with natural processes over decades produced results impossible to achieve through industrial shortcuts designed to satisfy immediate construction schedules rather than structural permanence. The fundamental lesson embedded in Horyuji's survival became clear to craftsmen who understood that true building permanence required methods that worked with biological processes rather than against them. Shigemitsu's techniques had achieved what modern pressure-treated lumber could not: genuine preservation through biological understanding rather than toxic intervention, creating timber that outlasted empires while maintaining structural integrity that continued supporting one of humanity's most important architectural treasures after 15 centuries of continuous service. The 20th century brought sophisticated analytical instruments that finally revealed the microscopic secrets behind Shigemitsu's seemingly primitive timber preparation methods, as wood scientists at Kyoto University subjected samples from Horyuji's 1,400-year-old structures to examination techniques that would have seemed like magic to the ancient master carpenter. Electron microscopy revealed cellular structures that remained virtually unchanged from their original condition, with cell walls that showed no signs of the brittleness or degradation typical of aged wood. The lignin polymers that provided structural strength had actually increased in density during the extended preparation process, creating timber with load-bearing characteristics superior to freshly cut lumber despite 14 centuries of service. Chemical analysis of the heartwood samples exposed the sophisticated bioengineering that occurred during Shigemitsu's standing death process, as natural compounds had polymerized into preservatives more effective than any synthetic treatment developed by modern industrial chemistry. The tachikare method had concentrated fungicidal terpenes and phenolic compounds throughout the timber's cellular structure while eliminating the sugars and starches that provided nutrition for decay organisms. This natural preservation system proved so effective that boring insects and wood-destroying fungi simply could not metabolize the aged heartwood, explaining how structures exposed to Japan's humid climate for over a millennium showed negligible biological deterioration. Modern pressure-treated lumber, by contrast, began showing failure after 50 to 100 years of service, despite toxic chemical treatments that made the wood hazardous to handle and dispose of safely. The industrial preservation process relied on forcing copper, chromium, and arsenic compounds into timber under high pressure, creating initially effective but ultimately temporary protection that gradually leached from the wood over decades. Shigemitsu's biological approach had achieved permanent preservation by working with natural wood chemistry rather than against it, transforming living tissue into material that decay organisms could not process rather than poisoning them with toxic compounds that eventually dissipated. The vindication of ancient wisdom extended beyond mere preservation, as structural engineers discovered that Shigemitsu's extended preparation process had created timber with mechanical properties unachievable through modern rapid drying techniques. Kiln-dried lumber, processed at temperatures exceeding 400 degrees Fahrenheit to reduce moisture content within weeks, suffered cellular damage that compromised long-term structural performance. The violent moisture removal created internal stresses and microfractures that made modern lumber more prone to splitting and warping under load, while the rapid temperature changes destroyed many of the natural compounds that provided strength and flexibility. International building code organizations began recognizing traditional Japanese timber preparation methods as superior alternatives to industrial processing after comparative studies revealed the remarkable performance advantages of naturally aged wood. The standing death process allowed moisture to migrate slowly through cellular structures without creating the internal tensions that plagued kiln-dried lumber, while extended seasoning periods permitted natural chemical changes that strengthened rather than weakened the final product. Modern architects working on high-performance wooden structures increasingly specified traditionally prepared timber despite significantly higher costs and extended procurement timelines. The restoration of damaged historical temples provided dramatic demonstrations of the quality differences between traditionally prepared and modern lumber, as craftsmen working on centuries-old structures discovered that replacement members needed to match the superior characteristics of original materials. When the Kinkaku-ji's Golden Pavilion required reconstruction after arson in 1950, traditional Miyadaiku insisted on using tachikare-prepared hinoki cypress aged for minimum 15 years rather than accepting kiln-dried substitutes that would compromise the structure's longevity. The painstaking restoration process confirmed that modern shortcuts could not replicate the dimensional stability and preservation characteristics achieved through patient traditional methods. Contemporary Japanese temple construction projects mandated return to traditional timber preparation techniques that had been abandoned during rapid industrialization when speed and cost reduction took precedence over structural permanence. The Japan Cultural Properties Protection Law required that designated historical structures use only traditionally prepared materials for any restoration work, acknowledging that modern processing methods produced inferior timber, unsuitable for buildings intended to survive centuries rather than decades. Master carpenters began re-establishing the ancient Miyadaiku training systems that preserved knowledge of tachikare and kusare dome techniques through direct apprenticeship rather than written documentation. Horyuji's continuing structural integrity after 14 centuries of service provided irrefutable evidence that traditional Japanese timber preparation methods achieved results impossible through any industrial process developed by modern technology. The pagoda's central pillar, carved from Shigemitsu's original 594 cypress, continued supporting the five-story structure without measurable deflection or deterioration, despite carrying loads that would challenge modern engineered lumber. Periodic structural assessments confirmed that the ancient timber retained full load-bearing capacity while showing remarkable resistance to the environmental stresses that destroyed conventionally prepared wood within decades. The fundamental lesson encoded in Horyuji's survival transcended mere construction techniques to demonstrate broader principles about working with natural processes rather than attempting to circumvent them through industrial shortcuts. Shigemitsu's patient approach to timber preparation had recognized that truly permanent materials required biological understanding and acceptance of natural timeframes rather than forcing rapid results through artificial acceleration. The standing death process worked with wood's cellular structure to create lasting preservation through chemistry rather than fighting biological processes with toxic interventions that provided only temporary protection. Modern sustainable building movements embrace traditional timber preparation methods as examples of how patient craftsmanship could achieve superior results while avoiding the environmental damage caused by industrial wood processing. The Tachikare technique required no fossil fuels, produced no toxic waste, and created timber with performance characteristics unmatched by energy-intensive kiln drying operations that consumed enormous quantities of natural resources while producing inferior materials. Shigemitsu's methods demonstrated that working within natural cycles rather than against them could achieve both superior technical performance and environmental sustainability. The ultimate vindication of Shigemitsu's seemingly wasteful methods came through recognition that his understanding of wood preservation had been 13 centuries ahead of modern industrial chemistry, achieving through patient biological knowledge what contemporary technology could not replicate, despite massive investments in research and development. UNESCO's designation of Horyuji as humanity's oldest surviving wooden structures acknowledged that traditional wisdom preserved through guild apprenticeship had solved preservation problems that continued challenging modern materials science. The pagoda's central pillar stood as testament to the power of working with natural processes over decades, rather than forcing immediate results through industrial shortcuts that prioritize speed over permanence.